Hi, I'm Paul Kilgan from GKtuition, and in this video I want to talk to you about algebra. Now the question I've chosen to go through here is 2018 Paper 1 Question 1. In the first part of this question we're given three different equations with an x, y and z in the first two and just an x and z in the third one. If you have three equations and three unknowns, you can do a simultaneous equation to find the value of each one. Now as you can see, I've already worked this one out. This was actually easier than the ones you're probably used to because there's no y in equation C. So the easiest thing to do here is actually try and eliminate your y's from A and B. So if you have a 3y here and a 2y here, you want to turn one of them to plus 6, one of them to minus 6. So on the right hand side here, that's what I've done. I multiplied the top line by minus 2. If you multiply the top line by minus 2, you get minus 4x minus 6y plus 2z equals 8. If you multiply the second line by 3, you get 9x plus 6y plus 6z equals 42. This is useful to us because I have a minus 6y on the top and a plus 6y on the bottom, so if I add the two lines together, my y's will cancel. 9x minus 4x is 5x, 6x plus 2z is 8z, and 42 plus 8 gives me 50. Well, my y's actually cancel each other out. So I've come up with a new equation and I've called it equation D. So if you look now at equation C is x minus 3z equals minus 13, and equation D is 5x plus 8z equals 50. We have two equations and two unknowns, so it's a simultaneous equation like you would have done at junior cert level. Now the easiest thing to get rid of, I thought in this case, was to get rid of your x's. Because there's a 5x in front in equation D, I want to have a minus 5x in equation C. So what I've done on the next line here is I've multiplied everything by minus 5. If you multiply everything in equation C by minus 5, you get minus 5x plus 15z equals plus 65. Just write equation D underneath it. It's 5x plus 8z equals 50. In this case, my x's cancel each other out, and 15z plus 8z is 23. 50 plus 65 is 115. Now to get z on its own there, you just divide both sides by 23, and you get z is equal to 5. Once you know z is equal to 5, you can sub back into either equation C or equation D. Because if you know z now, you can find the value of x. And in this case, what I've done is I've subbed back into equation D, except everywhere there was a z, I've subbed in a 5. And when you work your way through that, you end up with x is equal to 2. Once you know z and you know x, you can sub back into either equation A or equation B in order to find the value of y. So what I've done here is I've subbed into the equation 2x plus 3y minus z equals minus 4, except everywhere there's an x, I subbed in a 2, everywhere there's a z, I subbed in a minus 5. And I subbed in a 5, so your minus z becomes minus 5. Now if you work your way through that, you end up with y is equal to minus 1. Now just be aware there's loads of different ways of doing it. That's just the way that's the way I found probably most straightforward. If you did it slightly differently, that's fine as long as you got the same answers. You should have ended up with z equals 5, x equals 2, and y equals minus 1. In the second part of this question, we're given an algebraic inequality like so. There's a couple things that need to jump into your head straight away. If there's an inequality in your question there, your answer is going to be an inequality. It's asked you to solve this inequality, and your answer is going to be a range of values in the form of an inequality. Now the question told you that x cannot be equal to minus 2, but it doesn't necessarily have to tell you that. Just by looking at this question, you should be able to tell that x can't be equal to minus 2. Because if x was equal to minus 2, the bottom of this fraction would be minus 2 plus 2, which is 0. And in maths, we can't deal with a 0 on the bottom of a fraction because technically it's infinity. If you plug that into your calculator, it would be undefined. So they're not necessarily going to tell you this bit. You need to cop onto that yourself. In order to solve this inequality, you need to multiply both sides by the denominator squared. In other words, you're going to multiply the left-hand side by x plus 2 to be squared and the right-hand side by x plus 2 to be squared. When you do that, on the left-hand side, luckily, the x plus 2 on the bottom here cancels with one of the x plus 2's on the top. So in fact, you're just left with 2x minus 3 times x plus 2. And on the right-hand side, you just have 3 times x plus 2 to be squared. Now I've worked my way through this question here, and on the left you end up with 2x squared plus x minus 6, while on the right you have 3x squared plus 12x plus 12. Now clearly you have an x squared, an x, and a number, so this is a quadratic equation. So this is a quadratic inequality. So you're going to bring everything to one side, and then we're going to try and solve the inequality. So I've brought everything to the right-hand side, and I've ended up with 0 is greater than or equal to x squared plus 11x plus 18. So let's start this up at the top again. Once you have your quadratic, you substitute your inequality for an equals and you solve it. So I just ignore my inequality, make it an equals, and I factorize it. I get x plus 9 and x plus 2, which means my roots end up at x equals minus 9 and x equals minus 2. Now, they're not the answers. So a very common mistake here is that people cancel out their minus 2 there because they think x can't be equal to minus 2. Which, yes, if this was the answer, you'd have to cross that out, but this is not the answer. Remember, the only way you can do this is if the quadratic is equal to 0. When you find the roots, you're solving when it's equal to 0. So at the moment, we're ignoring the inequality. The reason we wanted to do it like this is because now I know what the roots are. Now I can draw a pretty good sketch of my quadratic. I know that this quadratic crosses the x-axis at minus 9 and the x-axis at minus 2. I know that it's a U-shape because it's a plus in front of the x squared. So the graph looks something like that. Now you refer back to the last line where you had an inequality, which is this one. The last time I had an inequality, the question is, when is the quadratic less than or equal to 0? In other words, when is this curve below the x-axis? This curve is below the x-axis when x is greater than or equal to minus 9 and when x is less than minus 2. So it's here. Rather than calling that a less than or equal to sign, you have to get rid of because x can't be equal to minus 2. So your answer is x is greater than or equal to minus 9 but less than minus 2. In other words, from here to here, the quadratic is below the x-axis. So your final answer in that case is this bit here. Now I hope that video makes sense. If you're unsure of any of that, then just send me an email or let me know in class and I'll try and clarify it for you and explain it differently.